This video, as our ELL-212 assignment, is going to illustrate plasma display in detail. Plasma television. It displays pictures from a video signal much like any television, except that to display those pictures, it relies on the fourth state of matter, plasma. But the question is, what is plasma? Plasma is an ionized gas consisting of positive ions and free electron in proportions, resulting in more or less no overall electric charge at low pressures and high temperature. Before delving deeper into the plasma display, let's talk about the technology base behind it. Before plasma display, cathode ray tube came into the market. Cathode ray tube. But what's that? It is basically a device that could fire out a stream of electrons onto the back of fluorescent screen. The parts of the screen being hit by electron would then glow. The basic functioning of the CRT is shown on the next slide. Then the electrons would run across the screen in a series of parallel lines, and the eyes on the other side of the display perceive a steady image. Early television had one of these electron guns, that means images used to be in black and white. But as the demand for bigger television and sharper images increased, CRT started to face a number of problems. As the size of the screen increased, they had to become deeper as well, so that the CRT tube could reach each and every corner of a screen. But apart from CRT, the television set can employ several available display technologies like digital light processing, liquid crystal display, light emitting diode, and organic light emitting diode. But the main focus of our video will be plasma display. Now comes the most important question: how the plasma television works. The screen on which pictures are displayed goes by name plasma module, and it's made up of two thin plates of the glass stuck to one another. More than 2 billion impulses are sent to plasma module every second, and the two glass plates of the module are covered with transparent electrode. But in order to convert these impulses into colored picture, it needs plasma, and this transformation happens between the electrodes in the pixel. Each pixel corresponds to one picture being displayed. Each pixel is further divided into 3 subpixels, and that coated with the phosphor that gives off light when excited by ultraviolet rays. When that happens, first give off red light, second give off green light, and the third the blue light. But now you will be thinking how UV light came into play. To answer this question, let's go more deeper into it. The answer is very simple. Each subpixel is filled with a mixture of xenon and neon, and when electrical impulse of about 300 volt is applied, electrons from the atom are torn off and suddenly start to flow freely, as a result of which state of the matter changes to plasma. But as soon as the discharge ends, the freed electron return to their places, and plasma once again got converted to gas. As a result of this process, electrons emit their surplus energy in form of UV light. It's UV that is responsible for glowing of the 3 subpixels, and by combination of each of these pixels, billions of the color light can be produced. Now let's talk about the advantages of the plasma display. It provides super contrast ratio and wider viewing angle, less visible motion blur, faster response time, superior uniformity, and unaffected by clouding from the polishing process. The images shown below compare LED or LCD with the plasma. In the first image, plasma display is shown on right, and we can clearly see that it provides a better viewing angle. In the second image, the image produced by plasma is shown on left, and we can see that it provides a higher contrast ratio in comparison to the LCD display. Now you will be thinking, is plasma display the best? Answer is no. We will see on the next slide what are the disadvantages that lead to permanent discontinuity in the production of the plasma display. Now, some disadvantages of the plasma display are: it uses more electrical power, it doesn't work well at high altitude, it may cause a buzzing noise. Earlier generation display had phosphorus that lost luminosity over time. It also has a shimmering or flickering effect. Reference
success.
This video was presented by Aditya
And Sourabh.
Hope you found this video helpful. Thank you.